Hello, my name is Brian Sharpener from Team 12. Also on my team are Jacqueline Lay and Catherine McCoy. I will be covering the problem definition and requirements section. This will be followed by proposed design section, covered by Catherine, and then justification of proposed design and conclusion and summary by Jacqueline. Our problem statement: to design and construct 3 instruments, 1 bar-based percussion, 1 string, and 1 wind, each of which will be used to play a separate portion of a song selected by the team. In our case, we have selected the song The ASU Alma Mater. All instruments, in our case 3 plus 1, must be capable of fitting into a single box that measures 2 feet by 2 feet by 2 feet. As you see here, this is an approximate example of how large that box will be. No more than 8 feet of pipe may be used by the team in total to construct the 3 instruments, no more than 4 feet of piano wire or guitar string as well. Additionally, a budget cap of no more than $15 per instrument may be spent for materials and supplies. This doesn't include tax or shipping expenses. All materials must have an assigned value. Only materials that are used should be considered in the budget, and painting there will be a flat $1 fee. Our top design goals: to create instruments capable of producing a quality track. That's what we want to do. Produce multiple tones from each instrument as well. Each instrument must be capable of producing a range of frequencies. Usability: the ease of use for our design option instruments is also considered a design goal. The constructability, the aesthetics, the creativity that has gone into each instrument and the design concept, and our ability to use resources effectively. I'd like to now pass the presentation on to Catherine, who will cover the proposed design section. Thank you.
Thanks, Brian. My name's Catherine McCoy, and I'm going to be going over our proposed design concept. To start out, for the high voice of the alma mater, we are going to be using a simply supported chime of solid steel bars that's going to be approximately 2 feet by 2 feet in the support structure. And for our medium high voice, we are going to be using a PVC flute that is actually going to be set up 3/4 of an inch by just over 28 inches long, that will actually have tone holes set for the varying lengths that we need and an adjustment in case of temperature or wind speed variations. For our medium, low, and low voice, we are going to be using a 9-inch cigar box guitar that is going to be capable of adjusting frequencies based on the gauge, tension, and length of the strings involved. This will meet our design criteria in the following ways. We will have 1 wind, 1 percussion, and 1 string instrument that are capable of operating in different voices. All of the instruments will have the frequency ranges necessary. 1 instrument will be played per part. All of them combined will fit into a 2 by 2 foot box. We will have less than 8 feet of pipe. We are actually at 7.4 feet total. We will have 3.5 feet of guitar wire, which is under our requirement of 4, and we will be spending less than $15 per every instrument. For our budget, we are going to have 5 feet of flat 1/8-inch steel, 42 inches of nylon thread, 8 feet of 2x4 lumber, 7 screw eye hooks, 8 wood screws of 2.5 inches, and paint, which comes out to a sum total of $12.33 according to our sources. For the flute, we will have 30 inches of 3/4-inch PVC pipe, 3/4-inch PVC pipe end cap of a slip joint variety, a 3/4-inch female-to-female connector, also of a slip joint variety, which brings the total cost to $1.75. For the guitars, we're going to be utilizing cigar boxes, 1 by 2 feet of 1 by 2 wood, 1/4 by 2 foot wood strip, a 1/4 inch by 1.5 inch bolt, a 1/4 inch by 2.5 inch eye bolt, 2 to 4 screws, wood glue, 3 tuning pegs, and 4 feet of acoustic guitar strings, which brings the sum total up to $14.70. This means that our design proposal is going to meet all necessary criteria within our budget constraints. Jacqueline, if you could go ahead and give us the justified design.
Thank you, Catherine. The justification of our proposed design includes looking at current design technologies and performances of similar systems. Our design concept includes a string guitar which covers the low frequency ranges and functions like an existing bass guitar. Our chimes and flutes cover the medium to high frequency ranges and functions as any flutes or triangles you would use in symphonies or orchestras. Our design concepts are based on real traditional instruments with historically proven success for being able to play a wide range of frequencies. Next, let's look at the equations and calculations for each of the instruments in our proposed design. First, we have the bar equation and initial parameters on the left. Using MATLAB, we solve for the length vectors needed for to play the alma mater in high voice, so that we know that this percussion-based instrument will be able to cover those ranges. Second, we present the wind equations and initial parameters on the left on the next slide. And using MATLAB again, solving for the length vector, we see that this flute will be able to meet the medium to high voice frequency ranges. Third, on the next slide, we have the string equations and calculations. And for the guitar in particular, we're going to have 2 strings that will be able to cover the medium to low and then the low frequency ranges. Our 3 design option comparisons are presented on slide 15. And with a different mix of strings, wind, and percussion instruments. And we utilize a decision matrix to quantitatively evaluate the 3 design options against what we've set as our criteria, and also weighted those criteria. You can see that in slide 16. And our option 1 with the using chimes for the high frequency, flutes for medium, high, and the string for low and low medium came out the top. So that's the design that we have chosen to go forward with. In summary, we've come up with the design concept of 3 instruments that will cover all of the frequency ranges needed to play the ASU alma mater song. Our top design goals were to create quality, track, and produce multiple frequency tones. Our proposed design meets all of the requirements and budgetary restrictions as presented earlier, and equations and calculations for instrument prove that they will be able to play those frequency ranges needed for the song. We used a decision matrix to help quantitatively evaluate our options, and we recommend proceeding to the building phase of this project. Thank you.